Okay, in the binomial expansion of a plus 4x to the power 6, where a is not equal to 0, the coefficient of determinant x squared is twice the coefficient of determinant x. Find the value of a. So because this is to the power 6, right, what I'm going to need to do is think of a plus b to the power 6 to start with. Yeah, let's get the general expansion of that. So you can see I've done Pascal's triangle here, and I've actually stopped here on purpose. Okay, you could keep going 20, 15, 6 and 1 to get all the coefficients. But you know what? All I need is the first 3 terms for the power 6 here. Because it doesn't say in the question, if you read it carefully, it doesn't say to expand the whole thing. Okay, it's just asking us to look at the coefficient of determinant x squared and the coefficient of determinant x. So actually, I only need the first 3 terms for that. So when I expand this here, okay, of course, we start off with a to that highest power, so a to the power 6. Okay, plus then, well, the second coefficient is 6. Reduce the a's then, so a to the power 5, and then b to the power 1. Plus then, next coefficient is 15. Reduce the a's, a to the power 4, and b squared. And I can literally stop there. Obviously, there's a lot more to the expansion, but I can put plus dot 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 to show that it continues. That's all I need. Now, in the one they've given me, I've got a plus, 4x to the power 6, okay? So what I'm going to do then, I'm going to replace them, what I need to replace. Now, a stays the same, doesn't it? Thank goodness, that's nice. The b, though, becomes 4x, okay? So, a to the power 6 I've got here, okay? Let's keep the a as it is, a to the power 5 there. B becomes 4x, so let's put it in a bracket, okay, because that's what b is, and then 15, a to the power 4, and then we've got to square b, haven't we? So remember, put it in a bracket because it's important to realise when you square b, okay, we're squaring all of this, yeah? That's what b is, so you've got to square all of it. So you're not just squaring the x, you've got to square the 4 as well, okay? Because that's what b is, square the whole thing. That's why putting it in a bracket will really help you here. Simplify it, well, you've got a to the power 6 plus, now here, put the number in front. So you've got 6 times 4 is 24, a to the power 5x, and here then, perhaps we take a little bit more time, I'll square this first, so I get 16x squared, okay, and then I times the numbers, right, 15 times 16 is 240, a to the power 4x squared. So what does it say? It says in the question, the coefficient of the term in x squared, okay, so when we're talking about the coefficient, we're talking about the stuff in front of it, right, so attached to it here, so the coefficient of the term in x squared is all of this, okay, it says then is twice the coefficient of the term in x, okay, so the coefficient of x is this, so let's go through that statement again. The coefficient of the term in x squared, so it's that, 240 a to the power 4, okay, is, it says, doesn't it, is, now is in maths is slang for equals, right, twice the coefficient of the term in x, so twice, double the coefficient of the term in x, which is 24 a to the power 5, so we're saying this is twice that, okay, this is twice that, so we write it as a statement here, 240 a to the power 4 is equal to twice 24 a to the power 5. Now what I can do then is, obviously I can work out what twice that is, so it's 48. And then, we're allowed to divide here, okay, because a isn't equal to 0, right? So what we can do is, we're timesing here, aren't we? So what I can do is get the a's onto one side and numbers on the other side. So because I'm timesing here, I could take that, for instance, a to the power 4 over the other side and divide, yeah? Because we're timesing here, take it over and divide. And I can do the same with the numbers then. Because I'm timesing here, I could take the 48 over and divide. Okay, so 240 then divide by 48 is 5. And a to the power 5 divide by a to the power 4. Well, rules of indices, take away the powers, so you just get a. So a there is what we're asked for, is equal to 5.